So this lecture is about the solid exercise of chapter number 6. So let's start this. So the first one is, let's say that choose the correct answer. First one is which of the following solution is more dilute? The first one is 1 molar, 0.5 molar, C 0.05 molar, and D 0.005 molar. So you can say this one is more dilute because 0.005 is the answer, because it is a more dilute solution because its concentration is too low than all these. So second one is milk is an example of A solution, saturated solution, B, C colloid solutions, and D suspension. So we can say that the correct answer will be colloid solution. So you can say that milk is an example of colloid solution. So number 3, water droplet in air is an example of solution. So A is gas in gas, B gas in liquid, you can say C is liquid in gas, D liquid in liquid. So the correct answer will be liquid in gas. This one. So C will be the correct answer, because water is liquid and air is in the form of gas. So by mixing the liquid in a gas, we will form a mixture of liquid and gas. Number 4 is when there is a low concentration of solute in a solution, it is known as number A, dilute solution, B, saturated solution, C, concentrated solution, and D, supersaturated solution. So when there is low concentration of solute in solution, the solution will be dilute. Number 5. What is the molarity of sodium nitrate solution made by diluting 250 cubic centimeter of a 1.6 molar solution to a final volume of 40 centimeter cube? So option A is 1.20 molar, B 1 molar, C 0.2 molar, and D 0.160 molar. So let's come towards calculation. We can say that what is the molarity of sodium nitrate solution made by diluting 250 cubic centimeter. So of 1.60 solution, molar solution to a final volume of 400 cubic centimeter. So in this case, 250, so this one will be the initial volume. So we can say this will 250 cubic centimeter will be the volume of initial volume V1, and 1.6 molar. This is the we can say initial concentration. C1 will be equal to 1.60 molar. And final volume, which will be V2, that will be equal to 400 centimeter. And we are going to determine the molarity of sodium nitrate solutions of final concentrations. So that will be C2 and C2 will be unknown. So if we put the formula C1, we know that C1 V1 is equal to C2 V2. This is the formula. So in this case, we are going to determine the concentration of C2. So this one, so this one. So C2 will be equal to, if we write here, C2 will be equal to C1 V1 divided by you can say V2. So in this case, C1 is this one, which is equal to 1.60, and V1 is this one will be equal to this one, 250. So put 250 here, 250 cubic centimeter divided by V1, V2, and V2 is equal to 400 cubic centimeter. So cubic centimeter will be cancelled with this cubic centimeter, and so by multiplying, you can say 1 point. In this case, we can say C2 will be equal to 1.60 of 250 divided by 400. From this, we will get concentration of 1 molar. So C2 will be equal to 1 molar of sodium nitrate. So we have answer of 1 molar. So in this case, this is the correct answer. Option B is the correct answer. So the molarity of sodium nitrate solution will be 1 molar. Option B. Next one is, what is the concentrations in percent mass by volume of a solution containing 15 gram KCl in 600 cubic centimeter solution? So you can say, so option A is 5%, B 2%, C 0.2%, and D 2.50%. So you can say that now we are going to determine this. What is the concentration of 1% of percent mass by volume of solutions containing 15 gram? So it's contain 15 gram of KCl, which will be divided by 600 cubic centimeter. 600 cubic centimeter. Because we know that percent will be the amount of gram in 100 ml solution. So by dividing 15 with 600 into multiplied by 100. So from this we'll get 2.5%. So the option is the correct answer, 2.50%. Number 7. When KCl dissolve in water, the following will be produced: A. K and Cl, B. K plus and Cl minus, C. K and Cl2, D. K plus and Cl2. So when KCl dissolve in water, it produces potassium ion plus chloride ion, K plus and Cl minus. So option B will be the correct answer. Number 8. 2 moles of sodium sulfate are dissolved in 1 cubic decimeter of solution. Molarity of a solution is, so you can say that we know that molarity. So in the options are given 1 molar, B 2 molar, 3 molar, C, or D 1.5 molar. So we have 2 moles of sodium sulfate. So we know that molarity is equal to mole per liter of solutions. So we can say we have mole, 2 moles, 2 moles divided by 1 decimeter cube. You can say 1 liter, 1 decimeter cube. So this will be equal to 2 mole per liter. You can say 2 molar. So the answer will be 2 molar, and that will be B is the correct answer. Number 9. Molarity is the number of moles of solute dissolved in 1 kg of solvent, B 1 kg of solution, C 1 cubic decimeter of solvent, D 1 cubic decimeter of solution. So molarity is the number of moles of solute per liter of solution. You can say 1 decimeter cube of solution. This is the correct answer. So molarity is the number of moles of solute per liter of solutions, because we know that 1 decimeter cube is equal to 1 liter. So this is equal to 1 liter. Next one is the molarity of NaOH solutions. The molarity of NaOH solutions by dissolving of 4 gram of ether in 250 ml of water is 0.4 molar, 0.8, 0.2 molar, and D is 0.1 molar. So we are going to determine the molarity of NaOH by dissolving 4 gram in 250 ml. So you can say that molarity is mole per liter. So we have 4 gram of NaOH, and you can say that formula weight of NaOH is 40 gram per mole. Gram and gram will be cancelled, and we have mole unit remaining, and volume is 250 ml. So we can say that 1 by 250 ml. So here we are going to obtain mole per ml, but molarity is mole per liter. So by converting the ml into liter, we will multiply this. We know that 1000 ml, 1000 ml will be equal to 1 liter. So in this case, ml will be cancelled, and we have a unit of mole per liter. So by multiplying 4 with 1000 and divided by 40 and 250, From this we will get know that 4 into 1000 divided by 40 into 250 mole per liter, and that will be equal to 0.4 molar. So the answer will be 0.4 molar, which is this one. This is the molarity of solutions which is obtained by dissolving 4 gram of NaOH into 50 ml of water. The next one is solve the following numerical questions. First one is, what is the molarity of a solution composed of 5.85 gram of potassium iodide Ki dissolved in enough water to make 0.125 cubic decimeter of solution? So the answer will be 0.281 molar. So how we will get this answer? Let's come towards calculation. So we know that we are going to determine the molarity of solutions composed of 5.85 gram of potassium iodide. So 5.85 gram of potassium iodide is dissolved in 0.125 cubic decimeter of solution. So we can say that the formula weight of potassium iodide will be equal to 166 gram per mole. So you can write here that 166 gram per mole of potassium iodide. Gram will be cancelled, and we have volume of 0.125 cubic decimeter. This is mole 0.125 cubic decimeter. So decimeter is also equal to liter. So you can say that 5.85 divided by write the same way, that 5.85 mole 0.125 cubic decimeter. So from this we will get 0.28 mole per decimeter cube. You can say molar will be equal to molar. So the answer will be 0.28 molar. So this is the answer we obtained in this way. Next one is, how many moles of sulfuric acid are present in 0.500 cubic decimeter of 0.150 molar sulfuric acid solutions? Answer is 0.075 moles. So how to get the answer? Let's come towards its calculation. So in this case, volume is 0.5. Cubic decimeter, and molarity is 0.15 0 molar. So you can say 0.150 0.150 mole per decimeter cube per liter. This is mole. We are going to determine the moles. So we have volume which is equal to this one 0.5 cubic of decimeter. So decimeter and decimeter will be cancelled, and we will get unit mole. So by multiplying 0.150 with the 0.5, we will get 0.075 mole. So this is the answer, which is equal to this one. So this is the determination of moles we have got. Question number 3 is, suppose you wanted to dissolve 4 gram of NaOH in enough water to make a 6 cubic decimeter of solution. What is the molar mass of NaOH and what is the molarity of this solution? So you can say that molarity of the molar mass of NaOH is equal to 40 gram, which is we already know. And let's come towards the option B. What is the molarity of solution? So we have 40 gram of NaOH, 40 gram of NaOH, and we know that formula weight of NaOH is 40 gram per mole. So gram and gram will be cancelled, and we have volume of 6 cubic decimeter. You can say 6 liter. So 6 cubic of decimeter a liter. So from this we will get the unit mole per cubic decimeter or liter. So by multiplying 40, by dividing 40 with 40 and 6, we will get the result of 4. So we can say in this case, 40 will be also cancelled, and we will get 1/6 mole per decimeter cube, and this will be equal to 0.166 mole per cubic or decimeter cube or molar. So this will be the answer, which is equal to this one. Number 4 is, what is the molarity of solutions of 14 gram of ammonium bromide in enough water to make 150 cubic centimeter of solutions? The answer is 0.9533 molar. So you can say we have molarity. Now we are going to determine the molarity of ammonium bromide. So we have 14 gram of ammonium bromide, 14 gram of ammonium bromide, and we know that we have a formula weight of ammonium bromide will be 166 gram per mole. So or we can say, sorry for the say, formula weight of ammonium bromide will be equal to 97.914. 97.914 gram per mole. So we have 14 gram of ammonium bromide, and this will be equal to 97.914 gram of ammonium bromide per mole. So this is cancelled with gram, and we have a unit of mole. So we have, you know that we have volume of 150 cubic centimeter, 150 cubic centimeter. So this is equal to ml. This will be equal to ml. So and we require mole per liter. So by converting the cubic centimeter into cubic decimeter, we know that 1000 cubic centimeter is equal to 1 cubic decimeter. So this will be cancelled, and we will get a unit of mole per cubic decimeter or mole per liter. So by multiplying 14 with 1000 and by dividing with 97 and 150, if we write here that we will get 14 into 1000 unit will be mole by dividing with 97.914 and 150 cubic decimeter. So from this we will get unit of mole per cubic decimeter, which will be equal to 0.950. Our unit will be mole per cubic decimeter. So mole per cubic decimeter, we can say it will be equal to 0.950 molar. 0.950 molar. So this will be the answer, which is equal to this one. So this way we can determine the molarity of ammonium bromide. The final numerical is, suppose you want to produce 1 cubic decimeter of 3.5 molar solution of sulfuric acid. What is the solute? What is the solvent? How many grams of solutes are needed to make this solution? We have 1 cubic decimeter 3.5 molar. So 3.50 mole per cubic decimeter, and we have a volume of 1 cubic decimeter, 1 cubic decimeter. So decimeter will be cancelled, and we will have 3.5 mole. And now we know that formula weight of sulfuric acid is 98 gram per mole. So by multiplying this with 98 gram per mole. Mole will be cancelled, and we will get 3.5 multiplied with 98, and from this we will get 343 gram of sulfuric acid. 343 gram of sulfuric acid. So this is the solution of numerical questions of chapter number 6. Thanks for watching.